Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 12 Physical Sciences exam prep on electric circuits. So, in today's video, we're looking at the Department of Basic Education's Physical Sciences exam paper 1 of November 2024. By now, you know the instructions of your examinations. It's important that you read all of them, and we are not going to read those instructions. So let's see. This question is a 21 marks question, right? 21 marks, meaning we should finish it in 21 minutes. Okay, we should finish it in 21 minutes, unless if there will be a lot of explanations. But let's see. Okay, let's see. L1 and L2, I see them, are two light bulbs that have the following ratings. L1 has 36 watt rating, 20 volts usage. L2, 48 watts, 32 volts. Okay. The two bulbs are connected as shown in the circuit diagram below. The battery has an internal resistance of 0.6 ohms, while the conducting wires and the ammeters have negligible resistance. R1 and R2, okay, R1 and R2 are resistors. Okay, interesting. 8.1. Okay, 8.1, let's see. 8.1 says, determine the term power. So it is the rate at which work is done. That definition you used on work, energy, and power is still valid here, okay? Rate at which work is done. Okay, it is the rate at which work is done. 8.2, if both light bulbs operate as rated, calculate the rating on ammeter A2, 8.2.1, right? So let's see. We're looking for the rating on ammeter A2. Okay, cool, interesting. What we know we can use power formulas. We have VI, or we can say power equals V. We can say power equals V square I. Oh man, what am I saying? V square over R, or power equals I squared R. All right. So let's see. For 8.2.1, which one do we have? Ammeter A2. This is for light bulb L2. We have power rating and voltage. We can find current. All right, so we'll use this one here. So we'll say power equals VI. So what is the power rating there? It is 48 watts. And what is the voltage? It is 32 volts. So the current flowing on ammeter A2 is 48 divided by 32, which is 1.5. So current flowing at ammeter A2 is 1.5 amperes. Okay. Current flowing on ammeter A2 is 1.5 amperes. Happy? Great stuff. Now let's go to the next question. 8.2.2. We are on the 4th minute now. 4 of 21. Let's see. Calculate the reading on ammeter A1. So to find the reading on ammeter A1, we might say the reading on this terminal, the current on this terminal, and the current on this terminal together are the currents on ammeter A1. Right? So let's do this. Power equals VI. We also have the power rating for light bulb L, isn't it? So what is the power? It is 36, and its voltage is 20. All right, its voltage is 20. All right, so I'm gonna say IL1 to say current on the L1. So 36 divided by 20 will be 1,8. Therefore, current on L1 is 1,8 amperes. Now, the current flowing at ammeter A1, will be equal to current flowing at ammeter A2 plus current flowing at L1. What is this? This is 1,5 plus 1,8, which is the total is 3,3 amperes. Right, the total is 3,3 amperes. Right, the total is 3,3 amperes. Okay, so that is the total current flowing at A1. Happy? Great stuff. 8.2.3. Let's see now. We are on 6th minute of 21. We are on the right track. Resistance of resistor R1. We already know the current flowing here, but we cannot really say we know the potential difference flowing here. However, I for one think we know the potential difference flowing here. I don't know about you guys, but I for one say we know the potential difference flowing here. Right? Can we say that? I do not know. Really, I do not know. But also what we can try is this. We can say the total resistance here equals the total current here and the voltage here. Okay, so I will say R equals V over I. The voltage, combined voltage flowing here, or combined voltage of this terminal, is the same voltage that is here. Okay, we already know the current here. We calculated it, isn't it? So what we know here, the voltage of L1 only applies to L1. It does not apply to R1. But the sum of it will be equal to the voltage here. Okay, so what do we know? The total resistance here, do we know it? Not really, we do not know it, right? So we will say, let's see. Okay, how do we go about this? Okay, we have to think. We really do not know the resistance flowing here. All right, we really do not know the resistance flowing here. So let me put it like this. I will say a voltage at R1 plus voltage of L1 is equal to voltage of L2. Why? Because these are in series. These are parallel, right? But these two are in series. This is why I'm summing their voltage. Okay? So we know R equals V over I. Therefore, or this implies V equals RI, right? And we know the current that is flowing here, isn't it? So we can say this is current L1, of course, we calculated it, resistance R1, plus we know the potential difference of L1, it was given, it was 20, right? And the potential difference of L2, it was 32. What was the current? The current was at L1 was 1.8. So we can say 1.8 times R1 plus 20 equals 32. So what is it? 1.8 R1 equals 12 volts. So 12 divided by 1.8 is, what is it? Are we there yet? Yes. R sub 1 equals 6.67 ohms. Right? So that is R1. R1 is 6.67 ohms. Okay. Happy? Perfect. Now let's go to the next one. 8.2.4. 8.2.4 says we must determine the nth of the battery, right? It says we must determine the nth of the battery. Already we know the voltage here. Do we know the voltage here? But we can find it. We can find it, right? We can find it. So now let's find V load. V load equals V of L2 plus V of R2. What is it? V of L2, we said it's 32. And V of R2, what is it? The total current was 3.3 amperes, right? The total current was 3.3 amperes, and the resistance here is 4. So let's get this. 32 plus 3.3 multiplied by 4. What is it? We find that V load is 45.2 volts, right? V load is 42.2 volts, right? So the reason I looked for V load is because I saw that looking for the RP and the R will take long. Hence, better if we look for the V load, right? So what we know nth equals V load plus V internal, right? If you like, we know that we can say this is total current, right? Which is current flowing at A1 times internal resistance. Now, what is this V load? We said it is 45.2. Total current was 3.3. Internal resistance is given to us as 0.6. Now, let's see. Now, we can therefore say nth is 47.18 volts. I want you guys to look at it once again. You guys got it? Remember, V load is looking at the potential, the sum of the potential of all the resistors in the circuit, right? In the external circuit. Okay? Perfect. Now we are good. Let's see. We are on the 13th minute of 21. Hoping we are on the right track. 8.3. Let's see what it says. 8.3 says bulb L1 burns out after a while. Okay? It burns out after a while. Right? Assume that the resistance of bulb L2 remains constant. Will bulb 2 continue to glow after? Okay. Will bulb 2 continue to glow after what? Continue. Will bulb 2? Oh, after bulb 1 burns out. Choose from yes or no, and then support your answer with a suitable calculation. Okay? Remember, you have already calculated the current that should be flowing at bulb L2, right? This is its power rating, right? This is its power rating, right? So let's see now. I'm going to leave a space to say yes or no, okay? Then I'm going to do a calculation, all right? I'm going to do a calculation, all right? So what I need is this. The reason I'm leaving a space is this. When bulb 2, okay, what's happening? When bulb L1 burns out, right? When bulb L1 burns out, we need to know what's going to happen. Remember, nth will remain the same. So what we need now is we need to know the external resistance and the current flowing when there's no L1. Okay, so let's do this. We're going to say power rating of L1 equals what do we need? We're not gonna use VI now, so we're gonna use. But even if we use VI, will it help? Yes, using VI will help. All right, let's use VI. Using V, what is this? Using VI, VL1 and I, which is one of this. So what is this? It will be, let's see now. What will it be? It'll be L1, it was rated 36 watts. L1 was rated 36 watts. And then voltage is 20. Is it? Are we looking at L1? No, L2. L2. Sorry, L2. So L2 was rated 48. Thank you. 48. And voltage is 32 volts. So what is 48 divided by 32? Right? So what is 38 divided by 42? Right? What is 38 divided by 42? So this we knew, right? This we knew. This is what we knew, but it is not answering the question. So now let's try to find, because we cannot be repeating what we had at, what is this? 1.5, 8.2.1. So now we want to know the total current. All right? We want to know the total current. So let's find resistance of L2. Okay? So we'll say power equals V square over R of what? L2. Okay, so we need to know that. Let's go. So this was what? 48 watts. And the voltage is 32 volts. We don't know what the resistance is. So now I see we need to say 32 squared over 48. What do we get? A resistance of light bulb L2 is 21,3333. Oh, so I'm writing 4 decimal places because I'm in the middle of a calculation. Okay, cool. So we already know this. Now we need to know the total current. Let's see. We will say M equals total current, R external plus R internal. What is M? M will never change. It is that 47,18. It is that 47,18. It is the total current that we do not know now. Now, what is the external? Remember, R1 is out. We are left with this guy here, which is 21,3333 plus 4 ohm. And what is the internal resistance? Even this one doesn't change. It's 0,6. So let's see now. 47,18 equals, I see it's going to be 25,9333I. Let me confirm. Right? Perfect. Now this 47,18 divided by that answer. What is our current? The total current flowing now. The total current flowing now is 1,82 amperes. All right? The total current flowing now is 1,82 amperes. Now, to answer the question, we can say this 1,82, all right, 1,82 amperes is greater than 1,5 amperes. This will burn the light bulb. Okay, this will burn the light bulb. Okay, so to answer the question, will bulb L2 continue to glow after bulb L1 burns out? Choose from yes or no. This light bulb L2, guys, it's made to operate only with a current of 1,5 amperes. This current is greater than 1,5 amperes. Therefore, your answer is simply no. Okay, your answer is simply no, and then it's followed by these calculations. Okay, and then it's followed by these calculations. All right, and this is how we do it, guys. I hope you are good. So, this is it. And this is all that you do whenever you come across electric circuits questions. Okay, so bye bye.